In this video, we're going to prove that the sum of a rational number and an irrational number must be an irrational number. And the suggestion here is to do a proof by contradiction. So we're going to let a be a rational number. So that means a can be written as n over k, where n and k are both integers. And we're going to assume that b is an irrational number, and our textbook uses the notation q complement for the irrational numbers. And our goal is to show that a plus b is also an irrational number, so it also belongs to q complement. And we're being told to do a proof by contradiction. So we're going to start out by saying, suppose, by way of contradiction, and in future videos I will abbreviate that by BWOC, by way of contradiction. It's often actually pronounced BWOC. So suppose, by way of contradiction, that a plus b is not irrational. Well, that means that we are assuming that a plus b is rational. So there exists m and l inside the integers, with l not being equal to 0. I should have set up here that k is not equal to 0. And a plus b is equal to m divided by l. Now, what that means is that a plus b is equal to m over l. And remember, we know that a is equal to n over k. So that is saying n over k plus b is equal to m over l. But that's going to tell me that b is equal to m over l minus n over k. And I know how to express this. That's m times k minus nl over kl. And that is a rational number, which contradicts the main hypothesis that b is an irrational number. And hence, a plus b must be irrational. And that ends this particular proof. It is worth noting that if a is rational and a is not equal to 0 and b is irrational, we prove a times b is irrational in the same way.